Good afternoon, everyone. Welcome to today's webinar on Norwegian hydrogen landscape, market, policies, and safety. I'm happy to see so many of you joining us from different parts of the world today. Today, we are explore Norway's hydrogen industry, its policies, and how the country ensures safety in hydrogen projects. Before we dive in, allow me to introduce myself and our esteemed speaker for today. My name is Prasadini Vikramsinghe, and I am the coordinator for the Greenstat Center of Excellence for Hydrogen. Today's session features Tor Kristian Haldorsen, the lead advisor, government relations at the Norwegian Hydrogen Forum. Tor Kristian brings extensive expertise in hydrogen policies, government collaboration, and international partnerships. His work with Innovation Norway and the German Norwegian Chamber of Commerce has shaped hydrogen development strategies on global scale. We are privileged to have him share insights into Norway's 100 years legacy of hydrogen production, its policy landscape, and how the country is leading in hydrogen safety and industrial application. This webinar is made possible through collaboration between Greenstat, SLTC Research University, and the Norwegian Hydrogen Forum. As part of our partnership with SLTC Research University, we are happy to support their knowledge sharing initiative, the Sparkwave project, as a knowledge partner. Also, a special thank goes to the National Science Foundation for promoting this event through their STMI's platform. Before we begin, here are a few quick reminders about the webinar recording. Don't worry if you miss anything. We will share the recording with you all or the registrants in the coming weeks. And also feel free to submit your questions in the Q&A session, Q&A box anytime. Then the questions will be answered during the Q&A session in the end. Now, without further ado, let's dive into today's session. Tor Kristian, the floor is yours.
Thank you very much, and thanks for the very kind introduction. It's a pleasure to be invited and to be able to talk for some 45 minutes or so about the Norwegian hydrogen landscape. And it's a lot to cover in those 45 minutes, both market policies and a bit on safety as well. So I think I should just jump right into it, and hopefully we'll have plenty of time for questions afterwards. So let me just share the screen here. So there we are. Yes, first some words about the Norwegian Hydrogen Forum, in which I have been working since the autumn of 2022. The Norwegian Hydrogen Forum is quite old in hydrogen terms. It was established in 1996 and is the national association for the hydrogen industry in Norway. We currently have some 100 members from the entire value chain, from production to distribution, usage, and storage. As you can see, there are some industrial companies, both from the onshore industry and the offshore industry in Norway. There are power producers, technology suppliers, and sub-suppliers as well, in addition to several research institutions, organizations, and some authorities as well. And if you are interested in learning more about our members, you may find an overview of them in the Norwegian Hydrogen Guide, which is available on our webpage, hydrogen.no. And you can also see where the different companies put themselves in the value chain. And as was mentioned in the introduction, Norway has almost 100 years of experience with hydrogen production. I believe 1929 will be the point of turning 100. So hydrogen is really closely linked to Norway's industrial history, and I believe that it will remain so. Hopefully, in not only in the next 100 years, but perhaps even for many more years. And why is hydrogen so important now here in Norway? Well, we have ambitious climate targets that have to be reached, where the Norwegian government, or let's say the parliament, has agreed that Norway shall be a low emission society in 2050. And that means that emissions in all sectors have to be reduced significantly to nearly zero. And there was just 2 weeks ago a new report released by the Norwegian Environment Agency, which maps the various emission cuts that have to be taken in the short term, or let's say the midterm, towards 2035. Because at the UN level now, the various member countries of the UN have to put forward a new suggestion for emission cuts towards 2035, and in that regard, the Norwegian Environment Agency has sort of tried to figure out where can the emission cuts be taken in Norway. And what we're seeing is that the hydrogen is one of the most central climate solutions towards 2035, and you can see that here on the screen, with hydrogen being relevant for several so-called hard-to-abate sectors, such as trucking, industrial processes, shipping, construction machinery and other machinery, public transportation at sea, and also aviation, and to some extent as well, power and heat at Svalbard, the island up north, in which coal has to be replaced with something that is without emissions. And what is interesting with the reports of the Norwegian Environment Agency is that each year they become more clear that hydrogen will play a pivotal role, especially in the maritime sector here in Norway. So we now come to the market development part of this seminar. I would actually like to start by zooming a bit out, because IEA regularly publish their annual Global Hydrogen Review, and the last one states very clearly that the number of projects increases, but only 7% of the announced projects have taken final investment decision. And I think the number was 4% in 2023, so it's increasing, but not nearly enough to reach the high ambitions that many countries have had. And the reasons for this is increased costs, higher interests, delayed and insufficient support schemes, as well as lack of regulation or unclear regulation. And Norway is definitely no different in this regard. We have seen in the last year that some of the large-scale projects in Norway have been either put on pause or delayed, or that the ambitions have been reduced as well. And the reasons for these are exactly the same as IEA has found. It's due to insufficient support schemes when it comes to industrial decarbonization. There are also challenges when it comes to power and grids for really large scale hydrogen usage in, for example, in fertilizer production. And also when it comes to large scale export of hydrogen from Norway to the European continent. The market is simply not there to go to the next phase of the maturing of these projects. And this is also to a high degree due to lack of regulation. Still some bits and pieces missing at EU level, as well as support schemes missing at the European continent level. So that has been sort of the main impression if you read newspapers, both in Norway and abroad, I think. But there is a very nice development still in Norway, and we are growing. The industry is growing. We just had the new numbers coming in for 2023, so we now see that the turnover in the hydrogen industry has almost doubled from 2022 to 2023, from 2.1 billion Norwegian kroners to 4 billion Norwegian kroners. And we believe that this will have increased further in 2024. So it will be exciting to see that when those numbers arrive next year. And we also see that the activity level rises. We started mapping Norwegian hydrogen projects in 2021, and we found approximately 50 projects. Now we have surpassed 200 projects, and that is all kind of activity. So we're talking about production. We're also talking about consumption, research and development, and also technology testing, piloting, demonstration, and scale up of manufacturing. And this map is available on our webpage in case anyone is interested in clicking on each project and reading more about it. So a very important part of Norway's hydrogen ecosystem is the R&D sector, and Norway has a very long history of doing research on hydrogen. And today, some of Europe's largest research and development projects on hydrogen are coordinated by Norwegian institutions. And in 2021, money was allocated for 2 research centers of excellence on hydrogen, and they are called Hydrogen E, led by Sintef Energy, and also High Value, led by Norse. And what is very, very exciting to see now is that some of the technologies that have been in development at the Norwegian research centers for many years are now starting to have reached the maturity level where they are being commercialized. For example, on the technology side, on the electrolyzer side, Hystar's PEM electrolyzer technology was originally developed at Sintef, and then Hystar was developed as a company, and they are now looking to establish large-scale automized production or manufacturing of these electrolyzers, both in Norway and in North America. On the carbon capture side, hydrogen production, Seg Power was similarly developed at the Norwegian Institute for Energy Technology, and the first installation is now being tested outside of Bergen on the west coast of Norway. And we look forward to seeing that facility now soon coming into commercial operation. What is also very important for the ecosystem is, if you want to get the technologies into the market, you have to ensure that they work. And of course, there are several hydrogen technologies that are mature, they're ready for rollout, but there is still a need for piloting and testing of new technologies throughout the value chain. So this requires us to have sufficient testing infrastructure in place. And right now we have world-leading testing facilities for maritime use at Stord, also on the west side of Norway. And also we have large-scale industrial testing coming this year at Herøya in Telemark. And in the National Transport Plan, which was presented last year, money has also been allocated for testing various low and zero emission concepts for aviation, and hydrogen-based aviation is one part of that, and will be tested from 2026. But still, the demand for test infrastructure is much larger than what is available. So we need to put our efforts into further improving this infrastructure. And some of the needs that we have is fuel cells at larger scale, liquid hydrogen, and also offshore wind in combination with hydrogen. There are several companies now working on concepts for both bottom fixed and floating hydrogen production at sea. I would like to mention also developments in the maritime space. The world's first liquid hydrogen ferry, MF Hydro, has been in operation since March 2023. And this is, I believe, one example of how Norway works with the energy transition in general, using public procurement as one of the main tools to ensure innovation in public transportation. So we have, I think, over 100 battery electric ferries in use now, and MF Hydro is the first hydrogen ferry. And this is due to very ambitious procurement strategies of the public procurers. And this ferry, of course, is also, I could mention that as well, the first on liquid hydrogen. It means that it can go 12 days without bunkering, which is extremely important. If it were to use battery, for example, it would have to recharge every time it's docking, and that would be very demanding. We are seeing several developments on the user side, which is very positive. I could start with the maritime sector, since I was just talking about MF Hydro. The next two ferries are in construction now, and will come into operation in 2026 in the northern part of Norway on the so-called Westfjorden line between Bodø and Moskenes in the Lofoten Islands. This is a 3-hour trip, a very long trip with harsh conditions, and these will be the largest hydrogen ferries ever built with compressed hydrogen. When it comes to industrial uptake of hydrogen, Yara's, I could mention first Yara's 24 megawatt electrolyzer at its Herøya plant was installed in June last year. It's the largest of its kind in Europe. But what is also very positive to see is that other industrial companies are also looking into hydrogen, such as Veidekke, which is Norway's asphalt producer. They have, I think, 15 production facilities for asphalt, and they have now begun phasing in hydrogen for heating purposes in this production at 2 facilities in Norway, which is very encouraging. On the heavy duty side, MAN has announced that they will deliver up to 100 trucks to Norway in 2025. And last year, the first heavy-duty refueling station that is publicly available was opened by Virion, and there is a plan to develop the first 2 corridors for heavy-duty trucking. And after MAN announced that they will deliver these trucks, many of the other truck producers announced that they will introduce the same and start serious production both of fuel cell and combustion engine hydrogen trucks from 2026. In the aviation sector, I mentioned testing previously, but also when it comes to the longer flight hauls, there is also a lot of work being done by Avinor, which is the state enterprise owning the 43, I think, public airports in the country, together with SAS and Airbus, and also Statkraft, the Norwegian renewables producers, collaborate on hydrogen-based aviation, looking to establish that by 2035. And lastly, what is very encouraging as well is that construction is increasingly becoming actually a very important market now in the first scale-up phase of hydrogen. In the last 2 years, hydrogen has been demonstrated with very good results at 2 construction sites in Norway, and delivering both power and heat at the construction sites. And now in the coming few days or weeks, not sure exactly, but very, very soon, the excavator that you're seeing in the picture to the left will be put into use for road construction in the northern part of Norway. And this is a very low-hanging fruits, I could say, to repurpose existing excavators and thereby instead of purchasing or building new excavators, you can make use of already existing equipment and thereby lowering the cost of the green energy transition. So when it comes to production, we have mapped 75 production projects in Norway, and 15 of these are either in operation, under construction, or have taken final investment decision. And further, 8 projects have received funding, but are still awaiting FID. So if you take all of the 75 production projects together, that would amount to a planned capacity of almost 8,000 megawatts in 2030. But if you look at the diagram down to the left, you can see how Norway's production capacity will expand towards 2029 on the precondition that all of the projects that have been allocated funding, that they actually reach final investment decision. So you will see that we will rise from 38 megawatts in 2024 to around 50 in 2025, 95 in or 96. There is 1 megawatt of low carbon hydrogen there as well. And then from 2027, we start to really see a high increase. And that is due to some really large projects being very close to final investment decision now, but not reached yet. So we will see how that goes. I would also like to mention that, as I mentioned earlier, the last year was difficult for the hydrogen industry globally and also in Norway. I talked about the large-scale projects having been paused or postponed, but still there has been a lot of, let's say, milestones being reached. 5 production projects came into operation in 2024. And there were also some investment decisions being taken, both production of hydrogen, production of ammonia, and also testing of hydrogen for recycling of aluminium at Norsk Hydro in Høyanger. And the Norwegian state enterprise Enova also allocated a record high support for hydrogen in 2024, around $258 million awarded to 11 hydrogen vessels, 13 ammonia vessels, and 5 production facilities for maritime application, which is around, no, not around, exactly 80 megawatts. So this is, of course, very positive, but we are also very, it will be very interesting to see whether the investment decisions will be taken. So far, we have had 1 investment decision being taken in 2025 by GreenH. For a 20 megawatt facility. This facility will provide the hydrogen for the 2 ferries that I mentioned previously. But of course, they are open to serve other customers as well. But most of the hydrogen will be provided for the ferries. So we have started the year quite well, and then we will see how well the funding schemes of Enova will work. At least they have really made a contribution to make funding available, and then we will see how well they are rigged for the industry and whether they will also contribute actually to giving investment decisions as well. So coming now to policy and regulations, I will start by just mentioning the barriers that we have. It's quite basic, some of it. The cost of hydrogen is high compared to the fossil alternatives. That means that there must be some kind of incentive to invest in hydrogen. It could be capex or it could be opex, and the price of the pollution is very important. If the cost of hydrogen is too high, that means that the cost of pollution is too low. So it has to be more expensive, become more expensive to pollute. Availability of hydrogen is low. That means that we have to do something to scale up production. We need a network of stations and bunkering. Electricity and grid capacity is vital, even in a country like Norway, where we have a surplus of both renewable energy and natural gas. And a lack of predictability in politics and incentives is a major barrier. And what I could say is that what we are seeing in Norway is slowly a positive development, that these barriers are in various degrees being handled. And I will now dig a bit more into that. Let's start with politics. There is a lot happening in the politics today in the last few days. Yesterday, actually, one of the two governing coalition partners, the Centre Party, which is sort of an agrarian periphery-based party, decided to leave government, which means that it's the Labour, the Social Democratic Party, that will continue ruling as the only party in government. It will be a minority government, but it will remain. It will continue to be based on the so-called Hurdals platform, which was agreed upon in 2021 when the two parties entered into their coalition. And what it says in that political platform is that the government seeks to build a coherent value chain where hydrogen production, distribution, and use are developed in parallel. They want to make capital available, and they also want to stimulate the development of hydrogen and ammonia for large ships and heavy-duty transport. In following up this government platform, the government has also established a so-called Green Industrial Initiative, a roadmap for new green industries. In this initiative, there are 9 different industries being mentioned, and hydrogen is one of them. Again, the goal is to establish a coherent value chain. And they also say that they want to produce enough hydrogen to meet the national demand in 2030, contribute to developing the European market, that means large-scale exports, and also to ensure that there is enough CO2 storage capacity to enable this large-scale hydrogen production from natural gas with CCS. So if we go a bit deeper into the policy and regulation, I have on the left side put in a picture of from the government's climate status and plan, which the government each year together with the state budget, they present a plan for climate emissions and emission reductions towards 2030 and probably also soon towards 2035 and 2050. So this is a way of accounting really for the emissions in the same way as they or make budgets for how much money goes into which sector. There is also a way of making a budget for how much money and what kind of tools will contribute to how many CO2 reductions by each year, and then towards 2030, etc. So if you see, if you look at the picture, it's sort of an overview of various measures for the shipping sector, and you have ferries, you have speedboats, you have service vessels, offshore vessels, you have cargo vessels, cruise ships, as well as the fishing vessel. And then that's up above, and then on the left-hand side, and then going down, it's fees, states funding, regulation, public procurement, as well as planning and spacing of the transport. So this is a very important tool that the Norwegian government uses to sort of align all of the various measures and understand how they will contribute to emission reductions in Norway. The most important measure is definitely the polluter pays principle, which is best pictured in the carbon price, which Norway has had since 1991. In 2025, the price for carbon, for 1 ton of carbon was 1,405 Norwegian kroners. That will rise towards 2,000 in 2030. So this is extremely important, and this is also coming as an addition to the EU trading scheme, which also puts a price on carbon, and in which Norwegian energy and industry, as well as aviation and also maritime industry, are part of that. Of course, risk relief capital, very important. Loans and grants, that has to be made available. And requirements in various sectors, low and zero emission construction sites is an important driver, for example, for hydrogen usage in construction, road building, etc. Zero emission ferries was introduced for 2025, so there is now a requirement for that, with some exceptions. As well as similar requirements in other shipping segments that are in planning. So they will come soon, I hope. And public procurement is definitely, as I mentioned earlier, it has been decisive in transitioning the ferry fleet and will be decisive, for example, for speedboats and the rest of the ferry fleet, which is much more hard to abate than the first 100, which were battery based. When it comes to the funding schemes, they are really, I must say, improving. In the last year, Enova has introduced new funding schemes and also improved many of the existing schemes. And there are now schemes for all of the sectors. I have listed here industry, maritime, and heavy duty, but also there is also funding available for construction machinery. These funding schemes are based on auctions, competitions, and the bids that need the lowest amount of support will win the support. So it's highly competitive, and that drives the companies to increase innovation in their offerings. And one important change that was just we just had this change before year end, so just a few weeks ago. And Enova, which is the state enterprise that is most important in the late phase of technology development and then rollout. Earlier, they sort of stopped at the demonstration. So if Enova's funding demonstrates that something is possible to do, then sort of the funding stops there. Now the mandate toward 2029 says that it's also possible to have a sort of a series of auctions, for example, to ensure the rollout. So not only the demonstration, but also rolling out and scaling up the various technologies that we need for the climate, to ensure that we can reach our climate targets. This is highly important. That means that we can have regular auctions, for example, for hydrogen and ammonia vessels, and also on the production side, hydrogen production and bunkering, and same in industry and heavy duty transport. So this is very important and showing that we are on the right track in Norway right now. And these support schemes are supplemented by various funding for research and development by the Research Council of Norway, as well as Gassnova, which is supporting CO2 capture, utilization and storage projects. But Innovation Norway also has a very important role in giving high-risk loans and grants, and there was a new scheme introduced last year that can also be used by the various hydrogen stakeholders. There are other let's say other support mechanisms as well. For example, by Export Finance Norway, but these are the most important when it comes to the financing of projects in Norway. And if you look at the support for hydrogen year by year, you see that it's been a large increase since 2020. And last year, Enova was definitely the most important among the various Norwegian agencies that are giving support with the green which you can see in green here, and the yellow is the Research Council of Norway. The blue is Innovation Norway, and Gassnova is barely visible in 2027 and 2018. But Norwegian companies also take part in various EU programs for research innovation, and that's a lot as well, and I can't mention it all, but it's important, I think, to mention that the Norwegian companies, both that are planning to produce or use hydrogen or also manufacturing, developing technologies, they are highly competitive in the EU programs. We saw in the last call in this autumn that Norwegian companies were awarded some 10% of the total funding. For example, the three electrolyzer producers, Nel, Hystar, Hydrogen Pro, there were also funding awarded for Statkraft and Equinor's projects in Germany and in Belgium. And we've seen both last spring and a bit earlier than that again, that some of the ammonia producers in Norway are competitive in these programs. So Skiga was awarded 81 million euros in the EU Hydrogen Bank pilot auction, and Fortescue also was awarded 200 million euro for its Holmanes ammonia production plant. And we could, of course, talk a lot about Norway's position in the EU. We are a member of the EEA, so we're not a member of the EU. But as a member of the EEA, we have to comply with the various EU hydrogen-related regulations to be able to compete on the same terms as other European companies. And to be a part of the internal market. So you see here the various hydrogen-related legislation that the EU has presented, and they are now coming into force, being implemented. Some of it has been implemented, and some is being implemented, and all of this will be very important for Norway's ability to compete in Europe and on the international stage. A few words about power and grid. We have seen now that several of the hydrogen producers, they have been granted grid connection, which means that they are now they can continue to mature their projects towards FID. But there is a challenge with long and cumbersome processes. It takes a long time to go from the first announcement of a project to receiving all of the permits, etc. And this is especially so when it comes to grid connection, and also to get the license for various licenses for power and grids. So for that reason, the state budget just before Christmas, the government allocated 68 million Norwegian kroners to streamline the internal processes in the Norwegian Water and Energy Resources Directorate. This is extremely important because when you have if the whole country is planning to electrify and you also have several industrial projects, it means that you need to expand the administrative capacity. So this is very important. And also standardization, digitalization becomes pivotal for the various agencies if they are to sort of handle the pressure that they are facing. So this is very good, and again, it's a good response to a challenge that we have had for at least 2 years. So we're seeing now that this challenge will remain a challenge, but maybe not so much as it has been for the last 2 years. And these uncertainties when it comes to grid connection, etc., these are most visible when you look at the existing industry. So existing industry parks where there is a project for decarbonization of the industrial processes. That is where also the challenges are most visible. So we need more electricity, even in a country like Norway, where we already have abundant renewable power from hydropower as well as wind. And one way to achieve enough electricity is to ensure that we have an offshore wind expansion and having regular auctions there. So coming now to the last part of this seminar, safety and skills. In 2019, there was an explosion at a refueling station here in Norway, which put our efforts in scaling up hydrogen back by several years. And it has been really an eye-opener for the industry. We cannot let this happen again. This is extremely important, and that is why we all work very hard to ensure this, and by sort of aligning everyone on the importance of this, from the smallest to the largest company, and together with the authorities. And when it comes to safe handling, we know what the properties are of hydrogen. We know that it's colorless, it's a non-toxic gas, it doesn't smell, it has lower density than air, which means that it will rise upwards and thin out into smaller concentrations. So the key here is we have to take all of this into account when we plan and design and operate the facility. We have regulation for this, the Fire and Explosion Protection Act, which is sort of the regular land-based industry, and then you have the Petroleum Act. There are some land-based facilities that are, I think it's 2 or maybe 3 facilities, and that are subjected to this act because they are receiving terminals of oil and gas from the offshore sector. And we are working very hard now and have initiated several packages, so to say, working along several lines. We have internally in our organization a safety working group. And there are also several working packages in the 2 research centers. There is a lot of standardization work going on internationally, and we have a Norwegian Mirror Committee called SNK 182 Hydrogen Technology, and that is being led by the Norwegian Directorate for Civil Protection. And Norwegian Hydrogen Forum is also a member there. But what we are seeing now is that the regulations that we have are to a large extent based on long experience from the oil and gas industry. So there are in the oil and gas industry, there has been standardization work going on by the industry for several years, the so-called NORSOK standards. So you have the norms, which means that the regulation that the hydrogen industry is based on is to some extent a bit vague, and that is especially in this startup phase or expansion of hydrogen into new sectors, perhaps not the way to go. So what we as an industry are asking for is for the regulation to be more specific to ensure that the various companies know what they can and cannot do. So a more detailed standardization framework is what we need to develop. And this needs to be done in dialogue with the safety authorities, of course. And that is something that we are now looking into doing in a joint industry project that we hope will begin very, very soon. We have been working on this for over half a year, so I hope that we will begin very soon. It's very important. And in relation to this, we need skills. Today, there is a challenge with recruitment to various technology courses, etc., both on the vocational side of the education system and also in higher education, universities. We need more recruitment, and we also need to ensure that existing workforce has the relevant skill set to ensure safe handling of hydrogen. So there is a combination here of establishing new programs, ensuring that hydrogen is in the syllabus in the various courses, both at lower levels in the education system and the higher education system, and also that we introduce new courses for educating the existing workforce. And that is not only the people who are going to be working in the production facilities or at the fueling stations, but also project leaders. We have fire departments that are extremely important, and also public decision makers. They need to understand the properties of hydrogen. They need to understand the dangers of hydrogen if they are to, for example, ensure a regional planning and zoning, for example, that is sound. And we need teachers to be able to teach, or trainers to train. So that is something that we are working very hard on, and there are some initiatives on that as well in Norway. Mapping of the skills that are existing in Norway, the skill sets that are needed, and also the existing existing courses, what is needed to change, and what is good as it is. A lot is we don't have to change a lot, but we have to ensure that we have to ensure that hydrogen is part of that we can, for example, use equipment in all parts of the education system. So yes, I think that was a conclusion for now. I'm not sure for how long I've been talking, perhaps too long. But I hope that it was interesting, and I look forward to some questions.
Please submit your questions in the Q&A box.
So there was a question about the risks of hydrogen and how this is impacting new projects, cost of capital, delays in approvals, etc. Well, that is a good question. I'm sure that it is. There are delays in approval for sure. And also we have seen in Norway to some extent that approval has not been given due to, let's say, a misunderstanding of the risks of hydrogen. And that is, as I said, the explosion that we had in 2019 really set the industry back a few years. And for many that are not working in the industry, the various, yes, they know that hydrogen is highly explosive, but they don't know how the risks can be mitigated. And that is something that we see, especially in the public decision-making side here in Norway, and something that I think it's becoming increasingly aware in the various public authorities that this is something that they have to work on. But for now, yes, there has been challenges with that.
There's a question. What is the most successful policy from Norwegian government, and how important is green procurement?
Well, I think that's the answer. It's procurement is it's highly important. We would not have the world's first ferry on liquid hydrogen unless there was a demand for it in the public procurement process. That goes for the Vestfjorden ferries as well. So that is very important. But what is challenging is, of course, that the purchasers might not have the relevant budget to be able to purchase such expensive vessels or machinery or whatnot. So this is also a question of funding, who pays for it. And in Norway, of course, it is it is easier than in other countries to say that the state has to take the additional costs, because we have gained a quite vast wealth in our pension fund for many years due to the oil and gas income that we've had now for several years. So I suppose it could be easier, would be easier for, in Norway, but it is a very useful tool. And then there is always a question: how is it funded, by whom? And that is something I think each country has to decide for itself.
There's another question. What was the cost of 2019 hydrogen explosion in real terms?
In real terms?
Yeah.
So that is in amount of money or in value, or am I understanding it correctly?
Yeah, it should be in amount of money and.
Yeah. Well, that I'm not sure of. It depends, really. It really set back the hydrogen usage in the transport sector by several years, as I mentioned, and it meant that the company that was responsible for the charging stations, they finalized their hydrogen strategy and decided not to follow hydrogen at all. So they are now active in other segments in the heavy duty transport, for example, on biogas, I think, but not on hydrogen. So of course, it led to a failure of, or a lack of investment, or of further investments, and it also shut down the station, and it led to shutting down some other stations as well. Of course, for those companies, it was very hard.
Okay, the next question. What is the biggest barrier today to scale up the green hydrogen economy?
Biggest barrier is, as I mentioned, the costs of polluting versus the cost of hydrogen. So the fossil fuels are cheaper than hydrogen today. That is because we have not internalized the costs of polluting, of the CO2. So if you put a price, a correct price, hydrogen will become cheaper.
Mm-hmm. Shall I move to the next question?
I see there is a question about the average cost of electricity. It depends. It's becoming more variable as we are introducing more and more wind and solar power in Norway. As I mentioned previously, most of our electricity supply is hydropower, but we have now approximately 10%, I think, 9-10%. Wind power, and the first bottom fixed solar parks are now coming as well. That, of course, contributes to higher variability, which is also very good for, or not very good, but that means that hydrogen can become a flexible solution. So this trend is really contributing to also making hydrogen a more sound solution and part of the Norwegian energy system. So the average cost of electricity is, I can't remember correctly, or I haven't looked at it lately, but let's say 67 øre, so not kroners, but that would be like 0.56 euro cents per kilowatt hour, something like that, depending on the various electricity bidding zones. We have 5 of them, and there is a large difference between the north of Norway, in which we have very low prices, and the southern part, where there is more exchange with other countries, and where the prices are much higher. But in general, let's say 0.56 euro cents.
Let's move to the next question. Has Norway, Nordic Steel, attempted for green steel production through green hydrogen? What are the outcomes?
Yes, there is a project on green steel in Norway. So far, there has been a challenge with the support mechanism because, as I mentioned earlier, Enova has until now had a mandate to only support demonstration, and it's been difficult to support technologies that are already mature. So and electrolyzers are on the TRL level 9. So when it comes to industry, you could, for example, have support for the usage of hydrogen, purchasing the various tools to use the hydrogen in, for example, when it comes to steel. But there would be no support for the electrolyzer, so the production side would not receive the funding. But that has changed now, so it's now possible. We are slowly progressing, and I believe that there will be progress on that project that is planning to use hydrogen for green steel. But of course, there is a lot of money as well that has to be put into the baskets, and that depends on the state's budget, the coming state budget.
Next question. Is Norway or EU in general planning for green hydrogen production plans to increase production and lower the price of hydrogen to bring it somewhere near to diesel?
One more time. So if Norway is planning to...
Is Norway or EU in general planning to green hydrogen production plans to increase production and lower the price of hydrogen to bring it closer to diesel price?
Yes, definitely. I mean, the EU has a hydrogen strategy. They have also the repower targets for 20 million tons hydrogen, of which 10 million is production internally and or domestically, and 10 million import. In Norway, we don't have any targets, but as I mentioned, there is a strategy to ensure that there is enough hydrogen for domestic consumption and also to enable export of hydrogen to Europe at some point. And there are various mechanisms for that. I have discussed some of them, but there are many more. And then it was a question about the price again and reducing the price. What I am experiencing right now when I talk to the producers of hydrogen and also the potential consumers of hydrogen, be it in the construction sector or in the industry or in the maritime sector, they are saying that right now it may not be that it's the price of hydrogen in itself that is the issue, but it's the distribution cost. So if we ensure that we have enough hydrogen production facilities, for example, along the entire shore in Norway, we will significantly reduce the costs for hydrogen. And then, of course, we need further technology development, which will bring cost reductions, and we need to ensure that there is sufficient power in the grid, which will drive down the cost of electricity.
Next question. How important is testing and certification for developing a local supply chain for safety?
Yes, I think testing and having that infrastructure is very important, and I think that is one of the strengths of the Norwegian ecosystem. We have access to testing in Norway, but also some of our members have access to testing abroad as well, for example, in the United Kingdom. So that is very important. And then certification is definitely one barrier that I haven't mentioned, but I did mention that the center party left the government yesterday. And that is actually due to a disagreement regarding some EU directives, and the EU Renewable Energy Directive has some definitions of renewable and low carbon hydrogen that are very important for the Norwegian companies to sort of, they need to be part of the same regulatory regime as the EU. So they need to be able to certify their projects in line with the definitions in the Renewable Energy Directive. So as the Labour Party sort of had the final word in this dispute with the Central Party and will continue their government alone, and they will implement this directive, that means that we will be able to certify the hydrogen in Norway as renewable in line with EU regulation. And that's extremely important for the Norwegian ability to compete on similar terms in Europe. So it's also important for the other industries, for example, maritime shipping industry and aviation that will be using hydrogen.
Next question. Given that close to 50% of Norwegian economy from natural gas, what percentage of GPD is spent on green hydrogen?
Not so much, I think. I don't have a number on that, unfortunately. But last year, Enova provided around 3 billion Norwegian kroners in funding. So that's slightly below $300 million US. So that was last year.
Next question. What are the mature Norwegian technologies that could be part of a program for green hydrogen production in a country like Sri Lanka on a build, operate and transfer basis, if such possibilities exist?
I did not quite get that question, I'm afraid. Could you repeat that?
What are the mature Norwegian techniques that could be part of a program for green hydrogen production in a country like Sri Lanka on a build, operate and transfer basis, if such possibilities exist?
I am not sure if such possibilities exist, but I saw that there was a hand from a person with a Norwegian name, so perhaps there is someone here that wants to respond.
Sure. Thank you. My name is Sturle Pedersen, and I'm a chairman of Greenstat in Sri Lanka. So we have an office there, and we are working also with the government of Sri Lanka. We developed the green hydrogen roadmap, and we have also developed the regulations, policies, etc., together with other partners overseas in Norway with Gaxcon and of course the parent company Greenstat and other agencies as well. When it's coming to the BOO, Greenstat do BOO project, and it is based on technology from Norway. It's can be turnkey solutions, but it can be also with other technology partners, depending on the location and application. So if it's for maritime It will be a different solution than it would be on the land-based, and if it's a biomass facility or if it's splitting the molecule with electrolysis, then there is also different technologies, as you all know, when it's coming to it. Alkaline or PAM solutions, depending on locations again, and the application and the size. This is available, and we are working with project also in Sri Lanka, pilot projects.
Thank you, sir.
That was a great response. Are there more questions?
The questions have been answered. Do you have any more questions? So please submit your questions.
I see that there is another question about cost, and the cost is, of course, on the size, if it's 1 megawatt or half megawatt or 5 or 10 or 20. So but if we are talking about 1 megawatt, it's ranging from 2 to 3.5 million, depending on what kind of output pressure you need. So the compressors are quite expensive, and you want to gear it up to 450 or 700. So that needs to be done in 2 stages. But again, it's very difficult to give a kind of the ballpark number. But let us say 2.2 for a half megawatt to the 3 is kind of in the ballpark. But again, if you want to do bottling, and there is additions to this. But please just send us questions, and we will follow up on it. I'm sorry, I'm in a transit, so I am not available to participate. So I have to move on. But thank you very much, Tor. It was really interesting, and I'm very, very pleased to hear about the news and updates, and how things are progressing quite rapidly in Norway. And as you said, it has been some challenges, but the dragon is only lifting when you have the wind in the. So we will together, collaboration with all the stakeholders. I think that we are quite strong, and we have a clear vision for where we want to go. And I think that Norway has been a front runner, not only in technology, but one most important part is in the safety. And as you say, we are working on the Spadatum test facilities, or we are working with Gexcon on their test facilities, or in the Energy House. It is really nice to see how Norway are pulling in all the different stakeholders in the global scene, shift to, or for piping and so forth, or in transportation, or in the maritime sector. So again, I would say that collaboration is the key for success, and we will always meet setbacks, but I don't think that this train will be stopped. I think that we will be able to achieve our dreams and save the planet, hopefully sooner than later, and reduce the CO2 footprint, and leave this planet in a better position than when we were taking it over going forward. So thank you again. It was a real pleasure to listen into you. Thank you.
Well, thank you.
Thank you very much, Kristin, for this insightful and engaging session. And thank you for all the participants for joining us today. Have a good day.
Bye-bye.